maybe talk a little more about this multi-table problem. I guess maybe
Yeah.
just referencing another podcast, when we had Andy Pavlo on the podcast with our CEO Bob had asked him, why are there so many databases? And so I think it's maybe an interesting topic. Just why are there
Yeah,
so
I
many?
gotta watch that episode with Andy because I'm curious what his take is. So yeah, it's not a multi-table problem per se, it's a multi-database problem. And the reality is, right, different databases are optimized for different types of workloads. Like we have transactional databases, we have analytical databases, people have data warehouses. There's vector databases now, right? There's Weaviate, and simply like everyone needs all of these workloads. So you have all of these databases. And another aspect of the thing is often, there are like NoSQL databases. For example, Mongo is very widely used and it has certain types of data, like maybe customer data or like more static data lives in some of these databases. And people just, naturally use whatever database makes sense for their needs. And then they end up having, tens, dozens of databases. Um, so the multi-database problem is quite real and that people need to be able to work through all of it. And I think what was interesting for us to start working on this data agent benchmark was that there wasn't a single there are at least 25 data agent benchmarks that I saw out there. It's not like we had the first idea to have a data agent, but not a single one of them really realized of the complexity of the problem of there being multiple databases. So it felt, like okay, we have to come up with a new benchmark.
I think maybe like the first thing that comes to mind, and I also love the collaboration with Hazara. Is
Hmm.
I had came across their booth at AWS reInvent like 2 or 3 years ago or something, and
Nice.
they explained this like you give us a bunch of different APIs, and we create like a unified GraphQL API. And so I think that one's interesting because it kind of contrasts with like the data warehouse, data lakehouse, and it's like, do I need to move all my data into the same table that I'm querying, or do I just kind of have like this API on top? But
Yeah.
I think maybe the transition from your last point about talking about like Mongo as well as like Postgres or say Weaviate is, and then like this kind of query operator concept. And is that maybe how you see it? The challenge with multi-database querying is like they have different operators, and you can't just like text to SQL because they have. This,
That's part of it. It's not so a lot of these databases actually share the same operators, right? There's many SQL databases even that a company might have. Like they might have both a data warehouse and their own like MySQL databases happening for their random applications. They're both SQL databases, right? They're optimized for different things. So operators might be similar, but it's just the artifact of how the company evolved. They just put data and they have workloads in different places, but unfortunately to do some sort of analytics or to have intelligent queries, they need to be able to join data from both. So yes, to your first point that text to SQL is not enough because you can't have a single SQL statement that unifies data from all the databases. But it might be SQL databases, might be NoSQL databases. It might even be like Hasura's. I'm glad you brought them up because we've had so many conversations with them as part of this collaboration, and they say things like, "Oh, Slack is a big data source. Salesforce is a big data source, and Salesforce is their own like Salesforce QL. I cannot remember for the life of me. Um, and yeah, like it just is that information has to be shared throughout all of it.
yeah, and yeah, I guess it's like with the different SQL databases, they could have still different storage engines, and people just I think either the developer experience or they know how to debug a particular one, and so that kind of like why are there so many databases like, in addition
Yeah.
to the data models? Yeah, yeah,
Yeah,
that
I mean that's we're not trying to get rid of databases. I think it's like our lens is that there's going to be multiple databases. Just that's the way the world is. And then now let's try to understand maybe what are the patterns and the kinds of queries people have. How do people join data across these databases? For example, maybe we'll get into this like properties of the data agent benchmark. But when something that we found is actually very hard to unify information across these databases because there isn't a join key that you would think. Like maybe you need to clean or deduplicate records or do some non-trivial processing in order to join. So there's a lot of these things that we systematically kind of uncovered from talking to Hasura and talking to a bunch of people and then coming up with the benchmark.
and that maybe motivates me to maybe jump topics ahead a bit, but that kind of like schema introspection, how like Weaviate, all these databases, they offer like meta APIs where you can query to get the schemas back. And but they're not really prepared for that kind of ill formatted join key. Like it's just is going to be like text string array. It's not going to be
Yeah.
like yeah.
Yeah, so I guess like maybe I'll talk a little bit about what we did in the data agent benchmark, right? We built the benchmark. Part of that is identifying what are the properties of the workloads that people want their data agents to run. And then two, like constructing real world synthetic kind of queries to match those properties. And then another thing that we did was like really benchmark actual AI agents on running these queries and just see how well do they do. Spoiler, they do very badly. I think our best agent is like 37%, 34, 37% like pass and one accuracy over 50 trials. But here we really found that, the just the schema discovery to your point, right? Like maybe that'll tell you what the schema of a table is, but the agents need to really go and drill and figure out what is in the table, like learn about other statistics of the data. For example, if they want to be able to join columns, you can't just hypothesize cleaning logic in your head, right? You have to go look at the data and you have to see what cleaning logic applies to it, repeatedly try applying, the union of many different regular expressions, and then do the join. And I think like at least prior to benchmarking this agents, I'm like very Claude code pilled and Codex pilled, and I thought that agents are going to get this right. They're so good at just like looking at data and making it work. But we were so shocked to find out that agents knew to try to look at the data. They'd like to do select star limit 5. That's looking at data. Limit 10, and then at a certain point they're like, all right, I got it. Let me guess the regular expression, and it's not correct. But they're like, it's good enough, and move on. So I'm happy to have the benchmark out there because I feel like you need some way for like, well, A, you need some way to benchmark progress, but B, it's nice to like have something that really tells us here are the failure modes of the AI agents as of now. Like we tried the latest ones.